taken on both Passfield Drive and Grove Road is a whole house retrofit based on the principles of passive house. At the start of the works, we're looking at how we can improve the overall airtightness of the building. So one of the very first moves is to apply a parge coat to the external walls of both houses. This means that we can cover up any cracks that may have occurred in the brickwork and deal with the general porosity of masonry construction. So once the parge coat's been installed to the external walls in the houses, we need to provide continuity between these walls and across the ceiling. We didn't want to remove all the roof finishes, so we've actually run our airtightness membrane at ceiling level. At Passfield Drive, a flexible Intello membrane was used to create an airtight barrier. At Grove Road, an 18mm OSB board was used to create the airtight barrier. The joints of the boards are tongue and grooved to provide additional airtightness, and these are taped. Airtightness membranes are cut around roof timbers and sealed to the parge coat. We've extended our external insulation below ground level. Using a water-resistant polystyrene-based insulation, we can create a thermal bubble beneath ground floor, which we believe will increase the thermal comfort within the house without recourse to a fully insulated slab as we'd originally intended. Above ground, the external insulation varies in thickness between 200 and 250 millimeters. In order to prevent a thermal bridge between our internal party walls and the exterior elevations, we're introducing wood fibre insulation with an integral moisture membrane to prevent any interstitial condensation building up in these areas. At both Passfield Drive and Grove Road, we've moved the windows out from their original positions using very simple timber frames placed on the exterior walls, which allows us to position the windows well within the external insulation zone, avoiding potential heat losses in that zone. The windows are taped back to the parge coat on the walls. In order to provide additional thermal comfort, we're therefore proposing a very thin layer of vacuum insulation over the top of the slab. At Grove Road, we've got to have a suspended timber floor, and in order to provide airtightness of this, we're proposing to replace the existing floorboards with orientated strand board, fully taped at all the junctions and taped back to the walls. A layer of geotextile membrane is laid over the joists, creating a trough which can be filled with 150 millimeters of mineral wool insulation. At ceiling level, a layer of 100 millimeters of mineral wool insulation was placed initially between the ceiling timbers below our airtightness membrane. Above the airtightness membrane, a further 300 to 400 millimeters of loose insulation or mineral wool in the case of Passfield Drive. Heat generated by the occupants, by appliances, even by household pets will add to the internal heat within the house. Both houses will be fitted with solar thermal panels. These provide hot water for domestic consumption. Generally, it's expected that 70% of the house's annual hot water demand can be provided through the solar thermal panels. We're also benefiting from solar gains through the south-facing or east and west-facing windows. In order to provide fresh air to the house without losing the heat that has been built up from appliances, occupants and solar gains, we use a heat recovery ventilation system. The fresh air, pre-warmed by the heat exchanger, is distributed to the bedrooms and living rooms within the houses. Filters within the unit allow us also to filter out any particulates or pollutants from the outside air. Following completion of the retrofit, the expected energy consumption of both Passfield Drive and Grove Road are expected to be reduced by in the region of 80 to 95%. The specific heat demand required at both houses should be below 25 kilowatt hours per metre squared per annum.
I didn't realise how much was involved with actually getting the building airtight. It was it's quite a colossal sort of task, but it seems to be all working, and No, it's a good system. I think it's brilliant. The things I've learnt about this project is that it's just not like a normal building project. It's not like everything you do you have to be 100% ensure in, like, just being aware of this air tightness is so critical. Just so far what I can see, the benefits of the solar and the windows are so much better, just leaps ahead. So that's what I would take with me. This was the bay construction. We had to have the whole bay out, starting from the bottom. We worked our way up. We cladded on some 6x2s around the outside of the building with chemical bolts, sat the bay window down onto them. They all had to be airtight, all the windows had to be airtight, wrapped around the 6x2s into the parge coat of the outside of the building. We worked our way up. There was a lightweight brickwork on the first floor, which all had to come out. This Atello has to come from the loft all the way down, taped around each individual rafter, and then between the rafters down to the wall plate, and then from the wall plate down to the parge coat, and that's sort of quite a hard detail to do, especially with all these hips and things like that. And that's the real thing that you've got to be quite thorough on.
Been asked by Anslow Homes to carry air tightness test on this dwelling here in Grove Road. Brand new passive house buildings will have a target of 0.6, but this one is 1. In layman's term, the main idea of air tightness is to make sure, basically having a way whereby heating is not escaping from the dwelling for the occupants, thereby driving down the cost of heating.
This is Passfield Drive, which is aiming for the Retrofit low energy standard, which requires an air tightness of 1 air change. That's the target. But here we are, ready to test the house.
Well, we depressurize and pressure, basically blow air into the dwelling and suck air out. But before we do that, we do a calculation of the volume of the building that we're testing. We know how much air we're pumping into the house, and from our calculations and our software, we know how much air is leaving. So we'll do also a calculation, so we have an actual air permeability for the dwelling. Like I said, the target for this one is 1, so it's really it's a big challenge. While the building's under positive pressurization, we have a handheld smoke pencil. We can puff around to see where there's any gaps in the fabric. Where you would normally find gaps is usually around window details, around doors, around service penetrations.
The final air test that we had was 1.65, but due to being such an old house and it's not very easy to get a retrofit to get under 1, but 1.65 is still a very good result.
This is the real challenge, delivering air tightness, good levels of air tightness in existing buildings, especially in cases like this where the residents are staying in situ. It's not a decant. Because also, these are people who can't afford their fuel bills.
But as soon as the windows were installed, we felt the difference.
And it's really going fantastically well.
It's not as big an upheaval as I thought it would be.
And everybody that comes in, they seem to be lovely, friendly people. They do put us first and foremost. They put our needs first. It's just occurred to me that now that we've got these new windows in, we've got a little bit deeper space here. And if I've someplace to put my flower pots, my orchids will have a brand new home. At the moment they're sitting on the floor.